Well, hey there, kiddos. Today we are going to talk about solving systems using elimination. This is part 2, so we're still eliminating like we did in class today, but we're going to add a step to what we were doing already. So the first question on your note says, suppose you were asked to set up a fair fight between 2x and negative 4x. The question is, would they be equal but opposite? In order for there to be a fair fight between two things, or two people, they technically need to be able to knock each other out or eliminate each other. And so I need these two things to eliminate each other. So thinking about what we were doing with elimination, and I need to eliminate 2x and negative 4x. I need these to cancel out. The only way for that to happen is for them to be equal but opposite, which means this needs to become a 4x. Now I can make it a 4x by adding 2x, so I could add 2x to it and do it. But when we're doing elimination, we want to always concentrate on doing multiplication. So what could I multiply this 2x by to make it the opposite of negative 4x? Well, if I multiplied it by 2, this would be a 4x, this would be a negative 4x. Now I have a fair fight. They will knock each other out. They will eliminate one another. And as you can see, they are equal. So they have the same coefficient, but they are opposites. One's positive and one is negative. So yes, they would be equal but opposite. And our goal today is going to be to set up a fair fight between one of our variables so it can be eliminated by multiplying it by something so that they will be equal but opposite. And then we'll eliminate like we did. So look at your example here for number 2. All we're going to do for number 2 is just set up the system so that one variable will be eliminated. We're not actually going to solve them, we're just going to set them up. So we're going to take this a step at a time. And I'm going to warn you right now, I'm probably going to skip a question or two. We might not do every single one of these, but I do want you to see how this is going to work. So let's start with B here. If you look at B, and let's compare our variables, I got 2x and 4x, and then I have negative 3y and I have 6y. The first thing I'm always going to look for is, do I have variables that already have opposites? And do those opposites already have a factor in common? So can I give them a common multiple and easily turn one into the other? So here's what I mean. So like my y's here, I've got negative 3y and positive 6y. So they're already opposites. And I can easily turn this 3 into a 6 by multiplying it by 2. So that's what I'm going to do. I'm going to multiply this whole top equation by 2 so that this negative 3y can cancel out. So what will happen is I will end up with 4x minus 6y equals 14. That's what that top equation becomes. And then the bottom equation stays the same. I didn't change anything. And if you'll notice, if I now add these two equations together, those y's will cancel each other out. And so I have now set it up to eliminate. Okay, so those eliminate. So now let's look at C. If you look at C over here, I've got 3x plus 6y equals negative 10, and then negative x plus 4y equals 8. So I have opposites again. I got 3x and negative x. They're opposites of each other, but now I need them to have the same number. So if I took this bottom equation and multiplied it by 3, I should have equal but opposite x's. So the top equation stays the same, but the bottom equation is now negative 3x plus 12y equals 24. And so when I add those together, those x's will now eliminate. And so I have now set it up so that something can be eliminated and I can solve. So let's skip down here to E. If you look at E, I've got 3x plus 4y equals 7 and 2x plus 5y equals 9. First of all, I don't have anything that is set up as opposites. I don't have a positive and a negative anything. The other thing is 3 and 2, like when I got up here, I had my 3 and my 6. The common multiple there is 6, so it's easy to turn one into a 6. The other one is already a 6. It was the same here. I had 3 and negative 1. The common multiple was 3, so that was easy. But here, 3 and 2, the common multiple is 6, and 4 and 5, the common multiple is 10, which tells me when that happens, since one of them is not already the number I want, I have to multiply both equations. These x's are easier because the numbers are smaller. So I'm going to have to multiply the top one by 2 to make that a 6. And I'm going to multiply the bottom one by negative 3 to make it a negative 6 so that they will eliminate. So your top equation is now 6x plus 8y equals 14. And your bottom equation is negative 6x minus 10y equals 27. So now these x's will eliminate one another, just like before. So let's do one more and then we'll go practice. So look at D. I got 2x plus 3y equals 12 and 4x minus 2y equals 6. I do already have opposites. I've got a plus 3y and a minus 2y. The problem is their common multiple is 6, and neither one of them is already a 6, so I'd have to multiply both equations. But if I look at my x's, I got 2x and 4x. The common multiple between 2 and 4, the least common multiple anyway, is going to be a 4. And so I can easily turn this 2 into a 4, and that one is already a 4. I just need it to be a negative 4. So I could multiply this by a negative 2, so that became negative 4x, and then minus 6y equals negative 24. And then that top one could be 4x minus 2y equals 6. And so now my x's will eliminate and I can solve. Now if you wanted to get rid of the y's and you wanted to go ahead and multiply both equations, you could do that as well. This is just an easier option in my opinion. So now let's solve a few. Here are some steps. Okay, so here are steps we're going to use to solve a system of equations by elimination. And if you want to pause for a minute, write down these steps, copy them down, that would be great, because I'm going to only leave this screen up for another couple of seconds, and then we're going to solve. So over here on number 4, we're going to skip A. I just want you to know we're going to skip A because that's what we did yesterday. It's pretty basic and easy. We're going to go over here, and we're going to go ahead and we're going to go do B. So we're going to first of all set this up so that I can make variables eliminate, and then we're going to solve. Okay? So I've got 3x plus 5y equals 38 and 2x plus 5y equals 27. Well, they made this easy on me. I got a 5 and a 5. The problem is they're both the same sign. I need to make one of them negative. So I'm going to multiply this bottom equation by negative 1. You could do the top equation too. I just decided I wanted to do the bottom. So I'm going to rewrite the first equation, didn't do anything to it. The bottom equation is now negative 2x minus 5y equals negative 27. So I'm going to add them up. When I do that, 3x plus negative 2x is 1x. My y's cancel. 38 minus 20. So 38 plus negative 27 happens to be 11, so I get x equals 11. Now I'm halfway done. I got to plug this into either one of these equations to get what y is. So I'm going to use the bottom equation. I have 2x, so 2 times 11 equals, plus 5y equals 27. Well, that's 22 plus 5y equals 27. And when I subtract 22 from both sides, I get 5y equals 5. And then when I divide by 5, y equals 1. So my ordered pair solution for part B is 11, 1. So let's do one more so you can see how it works. So let's do D together, and then we'll practice this in class. So you got 3x minus 5y equals 34, and 2x minus 3y equals 22. So nothing is opposites. I also don't have anything that have the same coefficient. I don't really even have anything that the least common multiple shows up, because the least common multiple between 3 and 2 is a 6, and between 5 and 3 is a 15. So I'm going to get rid of my x's. I want to make this 3 a 6 by multiplying by 2, and I'm going to make this 2 a negative 6 by multiplying by negative 3. So top equation, 6x minus 10y equals 68. And then negative 6x plus 9y, because this negative and that negative makes a plus, equals negative 66. And so then I'm going to add them up. Alright, so I'm going to add them up here, and my x's are going to cancel. And when I do negative 10y plus 9y, that makes negative 1y. And when I add 68 plus negative 66, that's 2. So when I divide both sides by negative 1, you get that y equals negative 2. Now we plug it back in so we can get x. Let's use the top equation. So I have 3x minus 5 times negative 2 equals 34. Well, negative 5 times negative 2 makes positive 10, so I have 3x plus 10 equals 34. So when I subtract 10 from both sides, I've got 3x equals 24. And so when I divide by 3, I've got x equals 8. So now I have my solution, 8, negative 2. So this is what we will practice tomorrow. I will see you guys then, so have a good rest of your evening. All right.